Math 3. Whoops, Math 3, homework number 29. Alright, so here's number 1. Now just remember when you guys have negative, right, that is a reflection across the x-axis, and if you guys have -2, that is moving to the right. So just remember those transformations for the future. Now, vertical asymptote, right? So vertical asymptote is x is equal to 2 because you set the denominator equal to 0. So there's your vertical asymptote, x equals 2. Horizontal asymptote, so the degree of the numerator is less than the degree of the denominator because the degree on top is 0, degree on bottom is 1. So that means horizontal asymptote y is equal to 0. Okay, you guys graph both of those, and that's how we got both of those dotted lines. Now, remember, when we deal with these types of transformations, I'll write this out too. This is the parent, right? Remember that this function is the parent function. Now, your parent function is always in the first and the third quadrant, right? Now, since it reflects across the x-axis, that is why your graphs are in the second and the fourth quadrant, which is why they are in those spots. And then domain, you just take a look at the vertical asymptote, -infinity to 2, and 2 to infinity. And for the range, you look at the horizontal asymptote, which is -infinity to 0 and 0 to infinity. And there's your guys' graph. Here's number 2. So for number 2, the 2 in the numerator means it's a stretch by a factor of 2. The x plus 3 part, the plus 3 part means your vertical asymptote moved left 3 from the parent function. And that plus 1 means your horizontal asymptote moved up 1, which is why these are where your vertical asymptotes are. Remember, it's in the comparison of the parent function. Now, to find your vertical asymptote, you can remember that it's just left 3, or you can actually set the denominator equal to 0. So x plus 3, right? This is the denominator. Set that equal to 0. We get x is equal to -3, and then horizontal asymptote, we get y is equal to 1. Now, this is the reason why. This part, you guys, that has a horizontal asymptote of 0 because the numerator is less than the degree of the denominator. But if that's y is equal to 0, just that part, there's this plus 1. So y equals 0 plus 1 would be y is equal to 1, which is why your horizontal asymptote moves up 1. And remember, since this is from the parent function, it's gonna reside in the first and third quadrant. It only moves if you have a negative sign, okay? And then your domain is, this is from knowing your vertical asymptote, -infinity to -3, -3 to infinity, and your range is -infinity to 1, 1 to infinity. All right, so we're going to take a look at number 3. Okay, number 3. No holes, because after I factor, nothing cancels. Vertical asymptote is setting the denominator equal to 0. So the denominator is that one, so set that equal to 0. And then and then it's going to be -3. So vertical asymptote is -3. Horizontal asymptote. The numerator in the top is 1. The numerator in the bottom is also 1. So since they're equal to each other, the degrees, then you just look at the coefficients. Coefficient of 1 and a coefficient of 4. 1 over 4, y is equal to 1/4. X-intercept, you set the numerator equal to 0. So x plus 4 equals 0. Solve for that, -4, comma 0. Y-intercept, substitute 0 in for x. So we're going to get 0 plus 4 over 4 times 0 plus 3, which is 4 over 12, which simplifies to 1/3. So remember, your intercept is a coordinate, right? 0, 1/3. Okay, I plotted both of these on the graph, negative 4 comma 0 right there, and negative 0 comma 1/3 right there. And I did all that. Okay, now I did a test point, right? I did a test point over here. So since I know vertical asymptote is negative 3, I should do a test point to see where my graph will reside. So I did negative 4. I plugged that into our final equation, which is right there, and I got 0. So at negative 4 comma 0, your graph is going to reside in that section. So since negative 4 comma 0 is right there, I know that the graph will be in this box area. Now I have to test a point to the right of the vertical asymptote. I'm just going to do 0, and I found that earlier, which was the y-intercept. So I know the y-intercept resides in this box, which is the reason why I know that the graph is in there. Okay. And then domain, remember domain is affected by the vertical asymptote and the hole, but we don't have a hole. So negative infinity to negative 3 and negative 3 to 0. Negative union, negative 3 to infinity. For range, I look at hole and horizontal asymptote, but there's no hole. So horizontal asymptote, 1/4. So negative infinity to 1/4, union 1/4 to infinity. And there's number 3. Okay, number 4. So holes, right? I factored and I got that. I see that I canceled out x minus 6, so set that equal to 0 to find your holes, what you cancel, right? So holes at x equals 6. This does not have a denominator. Well, it's 1, but 1 cannot equal 0, so vertical asymptote's none. Horizontal asymptote, looking right here, I see that it has a degree of 2, and this has the highest degree of 1. 2 is bigger than 1, which means you're not going to have a horizontal asymptote, so that's none. X-intercept, set that the numerator equal to 0. X minus 1 equals 0, and you get 1 comma 0. Y-intercept, substitute 0 in for x, so 0 minus 1, that's going to give you guys negative 1, so 0 comma negative 1. So we plot that, and now for the graph. Now, I know it's a linear equation because if you guys look at this right here, f of x is equal to x minus 1. So I wrote that down right there. So since I know f of x is equal to x minus 1, I know that's a linear equation, 1 being the slope and negative 1 being the y-intercept. So when I go back over here, I graphed it right there, the y-intercept right, and then the slope is 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and that's how I made that linear equation. And then don't forget to write the hole down, right? The hole is at 6. So since the hole's at 6, I know that the hole will be at 1, 2, 3, 4, 5, 6, at 6. And the hole is going to be on the graph, right? Now, if you want the specific coordinates, we'll talk about domain. So domain, remember, you use a vertical asymptote in your hole for your domain. We don't have a vertical asymptote, but we have a hole. So negative infinity to 6, and 6 union, 6 to infinity. For the range, okay, so for the range, you have to look at your horizontal asymptote and you substitute the hole into the final equation. So f of 6, because that's where the hole is going to equal to 6 minus 1, which is 5. So we're using 5 for our range. So negative infinity to 5, union 5 to infinity. And that's how you guys do that one. So for 5 right here, I factored top and bottom, and then if you guys take a look at x plus 4s, they cancel, which means that equal to 0 is your hole, negative 4. Vertical asymptote, set that denominator equal to 0 for x plus 6 equals 0 for x equals negative 6. Okay, so horizontal asymptote, the highest degree is there 2, the highest degree is there is 2. So coefficient over coefficient, 1 over 1, which is going to be y is equal to 1. X-intercept, set the numerator equal to 0, so we're going to get x is equal to 4, so 4 comma 0. Y-intercept, substitute 0 into the equation, right? So 0 minus 4 over 0 plus 6, which is negative 4 6, which is negative 2/3. So 0 comma negative 2/3 is your y-intercept. And then I just plotted my vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. And I put down the whole. Now let's figure out where our graphs resides, right? So to test a point, grab your vertical asymptote and test a point to the left and to the right of 0. Left and right of the vertical asymptote. Okay, to the left of negative 6, I know is negative 7, so put that into the original equation, which was right here, right? So we're going to get negative 7 minus 4 over negative 7 plus 6, which is negative 11 over negative 1, which is 11. So I know at negative 7 comma 11, that's where my graph resides in. That's in one region. So that's going to be in this region right there. That's where negative 7 comma 11 resides in. And then test the point to the right. I might as well just use x equals 0 because that's to the right of negative 6. And we already found it right there, which was 0 comma negative 2/3. And 0 comma negative 2/3 resides in this one, which is why I know my graph is in there. Okay, and then I used my my asymptotes to help guide me in graphing it, right? That one, and then I used my intercepts as well to graph that one. And don't forget the whole is located at x is equal to negative 4. Which is right there. And remember, the whole is on the actual graph part, right? Not on the asymptotes, not on the axes, wherever the graph is at negative 4. Okay, so domain and range time, right? So for domain, we have to use our vertical asymptote and our whole. So I'm going to do negative 6 first because that's smaller than negative 4. So negative infinity to negative 6, union, negative 6 to negative 4, union, negative 4 to infinity. Okay, now for the range, I have to use my horizontal asymptote and I have to substitute my whole into the equation. So f of negative 4 is equal to negative 4 minus 4 over x plus, negative 4 plus 6. We're going to get negative 8 over 2, which is negative 4. So I know my whole for the y coordinate is going to be negative 4. So comparing negative 4 to y is equal to 1, I do the smaller one first. So negative infinity to negative 4, union, negative 4 to 1, union, 1 to infinity. Okay, so there's number 5. Number 6. I factored and then I realized that you could cancel, so set what I canceled equal to 0. So since I canceled x minus 5 equals 0, x is equal to 5. There's the whole. Vertical asymptote, set the denominator equal to 0. So we're going to get x is equal to 1/3. Horizontal asymptote, I see that the highest degree here is 1 and the highest degree there is 2. So numerator is less than the denominator, so that means y is equal to 0. X-intercept, 1 equals 0. That's not possible, so that's why it's going to be none, because 1 cannot equal 0. And y-intercept, substitute 0 in for there for your x's, and we're going to get 1 over negative 1 for negative 1. 0 comma negative 1. And then I plotted my y-intercept, my whole, my vertical asymptote, and my horizontal. Now for test points, right? Remember, test point is to the left of the vertical asymptote and to the right. X equals 0, 0 comma negative 1. We did that right there. So I know in the 0 comma negative 1 region, which is this one, my graph is going to reside in that location. And for x is equal to 1, we get 1/2. So I know 1 comma 1/2 is in this region, which is why I know to graph something there. Do your graph so that it's relatively close to the asymptotes, and then I know my hole is right there, because that's where x is equal to 5 on the graph. And make sure there's a hole, right? A gapping hole on the graph. Okay, domain and range time, right? So domain, look at your vertical asymptote in your hole. 1/3 is smaller than 5, so that means we do 1/3 first. Negative infinity to 1/3, union 1/3 to 5, union 5 to infinity. Okay, so range, you gotta use your horizontal asymptote, and you gotta plug in the hole into the final equation to figure that out, right? So f of 5 is equal to 1, 3 times 5 minus 1, which is 1 over 14. So I know to use 1/14 as part of my range. So 0 is smaller than 1 and 14th. So negative infinity to 0, union 0 to 1 and 14th, union 1 over 14, comma, infinity. Okay, that's number 6. All right, number 7, this is the one that's kind of tough, right? So there's a lot going on. Okay, so let's go over here. All right, hole, there is none because nothing cancels, right? So there's none. Vertical asymptote, set the denominator equal to 0. So we're going to get x is equal to 3, negative 3, and x is equal to 3. Horizontal asymptote, highest degree here is 3, highest degree here is 2. So that means 3 is greater than 2, which means you're going to have no horizontal asymptote. Which means for slant asymptote, you gotta do long division. And we get 1/3 x minus 2/3, which for you guys, you just gotta graph something that's 1/3 x. What's that? Y-intercept of negative 2/3. That's how I graph that red line. X-intercept, set the numerator equal to 0. So that means we're gonna have x equals 0, x minus 4 equals 0, and x plus 2 is equal to 0. So we have 3, 0, 0, 4, 0, and negative 2, 0 for x-intercepts. Y-intercept, plug in 0 into the original equation, and we're going to get that it's going to come out to 0, 0. So we graph all those. Now, this is where we do a test point, right? Because the test point will help us to know in which region to graph this in. So one test point I did use was, what did I use? Oh, okay, something to the right of, so I know my vertical asymptote is at negative 3 and at x equal to 3. So I need to test a point to the left of negative 3. So if I did negative 4, negative 4 is going to be negative 4 times negative 4 minus 4 at a negative 4 plus 2. All over 3 times negative 4 plus 3 and negative 4 minus 3. Now I'm going to get negative 8 times negative 4 for 32. I'm going to get 32 times negative 2 for negative 64 all over 3 times negative 1 times negative 7, so that's going to be 21, so that's going to be roughly around negative 3 point something. So I know my graph is going to be in this region right here. In that one. Now, remember, you guys are just estimating, and I know this one's the most weirdest and strangest one, but for this section, I kind of already know it's going to be in this section, you guys, because look at where my intercepts are, right? My intercepts are in this middle portion, so I know it cannot be here. It can't be there. So that means it has to just be in that blue section. And for your other one, I know it's going to be here because I know one of the intercepts is in there, right? So again, you guys can test points. That's always the best, but, if you use your intercepts and stuff, that should generally tell you as well. Okay, so for domain, don't have any holes, but we got vertical asymptote, so negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Okay, so for range, notice that there is no holes or horizontal asymptotes, which means that your range is going to be all real numbers, so negative infinity to infinity. Again, this one's pretty challenging, you guys, but I think you guys can do it, okay? You guys are savvy enough to know how to do it. Okay, so this one right here. Now, this one, you guys, you have to make it from scratch. So, I'm gonna put these down so you guys don't get heavily influenced by this. And we're just gonna take a look. So this is how I go about it. Okay, so it says reciprocal parent function, right? So you know the parent function is this. And these, what we're about to create, is just a transformation of that. So since it says translate 5 units to the right, I know that's 1 over x. 5 units to the right, that means it is minus 5. 7 units down, which means I'm going to do minus 7. Reflect across the x-axis, which means that's going to be a negative sign for reflection. Write an equation that could represent the new function, then identify the asymptotes. Asymptotes for this one would be vertical asymptote is x equal to 5, right? Because the denominator is x minus 5. Set that equal to 0 for x equals 5. Horizontal asymptote is y is equal to negative 7. Because even though this part is y is equal to 0, y equals 0 minus 7 would just push it down 7 below, which would be that part. Which is why this is your guys' answer. You're going backwards, right? Last question, number 9. Write a rational function with an x-intercept at negative 9, 0. So this is kind of using your guys' going backwards, right? So if I have to make equation f of x, I first have an x-intercept at negative 9, 0. So remember, in order to find the x-intercept, you have to set the numerator equal to 0. Well, if we go into reverse, that means this is going to be x plus 9, right? Because if you set x plus 9 equal to 0, that's x is equal to negative 9 for an x-intercept of negative 9, 0. Which is why that's the first part. Next part says vertical asymptote at x equal to 3, which means the bottom had to have been x minus 3, right? Because if you set the denominator equal to 0, we're going to find an asymptote of x equal to 3. So there's that. Okay, we got a hole, right, at 1, negative 5. Well, to put a hole, that means something would have to cancel, right? And that would have been x minus 1 on top and bottom, right? Because if we canceled these, right, then when we found our hole, set it equal to 0, x would have equal to 1 for the hole. And that is how you guys create your equation, right? Then it says to find the horizontal asymptote. Degree of 1, degree of 1, degree of 1, degree of 1, which means that we tied, right? We tied in degrees, so that means we look at the coefficients, which is just 1 over 1, which is 1. So that is basically how you guys have found this information, just working backwards, right? So hopefully that helps you guys. If you have questions tomorrow, then just please let me know, okay? Peace.